in here is going to struggle with putting v. The situation which he gave you in this particular thing was so easy. You see, if you study your lecture, you see that it's quite nice. Look at this. What do we have? Let's replace. So if you have an x squared, let's start with the polynomial. If you have an x squared, anything with an x squared, even if L and M were 0, you need to put all of them up to x squared. Okay, a plus bx plus c. Here we have what? Only x. Again, so our v will have, first of all, our v will have ax plus b, because we only have an x. Okay, if we had an x squared, it will have ax squared plus bx plus c. You understand? So when it has an x only, it will be having ax plus b. You say this plus b, it's always there. The constant is always coming after the polynomial. Please make sure, right? Then what are we going to do now? Let's do for this. We say plus. We keep going. We keep going. Now we're going to put for this 3e to the 2x. So when you have an exponential, you're going to bring back the very same exponential, but the number in front will change. So it's going to be plus ce to the 2x, because the next letter here is c. That's the next constant we have available. Plus, now when you have here, we have 2 cos 2x. Now what do we have? So here we are having a cos thing. Whenever you have a trig, it will bring sine and cos together. When you have cos or when you have sine, it will bring them both together. Like if you see here, we had a negative 3 sine x, isn't it? But when we are going to put our thing, we have them both. D sine 2x plus e cos 2x. You understand? So what changes is just the number. So I have these 2 cos whatever. So I'm going to say plus d sine 2x, because that's the next letter. I've already put c, right? Plus now e, then this was a cos 2x, so it would be a sine 2x. If it was a cos 3x, it would be a sine 3x here. D plus e cos 2x. Both of them come back. Okay, whenever you have either a sine or a cos, and we don't care whether they are adding or subtracting, when you put in v, you always add them. So here I have my v. Do you hear me? Now let's go and see what will then happen. When you have your v, you are now going to need to have class. Look at where it's going to get interesting. When you have your v, you are now going to need to have the second derivative of it and the first derivative, so that you're going to put them here. Because on this d of v, you are going to substitute by the derivative of v. You hear me? So you should find what is dv dx. Okay, so d in this case is equal to dv dx. And what is it going to be? You're going to differentiate this whole thing. Then you're going to get d squared, which is going to be d2v dx squared, which you're going to differentiate the d. Okay, then you are now going to put, when I get d, you can get also 3d below it before you go to this other one, because you're going to need 3d. That's the one you actually had here. You're going to need 3d, right? Then you're going to need d squared. So you then get, when you have d, you then get your 3d. Then you're going to now get your d squared. When you have all of them, you're going to combine them. Okay, we are going to combine them plus 2 times v, which will be 2 times this thing here. Okay, and it will be equal to this other thing. Now when you say it is equal to this other thing, the last thing you would then do is to compare coefficients. Okay, so you'd say, okay, I'll compare all the coefficients of x. So anything which has an x, which in this case would be a plus whatever, you take the numbers in front of those things that have x, you make sure they are adding up to 2. Then you're going to take the coefficients of numbers, the coefficients of sine, the coefficients of everything, and you'll be just trying to find the missing constants, the a, b, c, d, and e. Okay, you'll be saying, so in other words, I don't have a sine this side, so the coefficients of sine will be adding to 0. I don't have but I have a cos, so the coefficients of cos will be adding to 2, because the coefficient of cos on this side is 2. Okay, I don't have a constant here, a number which is alone, so any numbers that will be here, anything that doesn't have an x or anything, should be adding to give me 0, and I combine them. That's what you would then do at the final step, and you'd be done. So there is differentiation involved, and a lot of people stay there. You got to differentiate this whole thing. Ax, it will be a, plus the derivative of b is nothing, plus here the derivative of ce to the 2x. What do? You bring it first. C is just a constant. You would have e to the 2x times 2, right? Okay, because it comes back, then you multiply by the derivative of this. So in actual fact, it will be 2ce to the 2x. So we can then rewrite it to say it is 2c e to the 2x. That's the derivative. Then we get the derivative of d sine x. D is just a constant, so it'll be d. The derivative of sine 2x is 2 cos 2x. Because you'd say, what is the derivative of sine? Is cos, right? Remember? Y, then y prime. The derivative of sine x is cos x. Then the derivative of cos x is negative sine x. So when I differentiate, now it's sine 2x, I'll get cos 2x, okay? But because it is a 2x and not an x, I'll then multiply by the derivative of the inside. The derivative of 2x is 2, so it'll be times 2, which will give me 2 cos 2x times d. So it'll be 2d cos 2x. You understand? Then you're now going to have, then you're going to combine them all into one long thing and whatever. I'm going to do it in the next video. Goodbye for now. But I wanted to make you see what we're going to do and what is coming. So I'll find the whole d, I'll multiply it by 3, then I'm going to find the whole d squared. Then I'll rewrite this whole thing here, okay? But I know my d squared v will be just this d squared. Then I say plus my 3d v will be just this 3d, because it's the 3d of v, because I'll be getting it of this v. Then I'll say my 2v will be just 2 times this whole thing, and that is what I write. Then I'll say it is equal to, then I put on the other side this thing here. Then I start to compare coefficients, okay? All of them, all the things that you had, you look for anything that has a sign, you look at the numbers in front, you add them to give the numbers with sign on the other side, and you're done. And you then combine the u and the v to get your y. You now say y is equal to u plus v. You take the u, you add it to the v, then you can now put your initial conditions and find the other constants now, okay? And we say to you, well done, bravo, you are done. You understand? How good is this? A lot of work, right? But it's doable. If you go step by step, you can do it. Goodbye.